Hello guys, welcome back to my channel. My name is Manas Adhikari and I'm 10 years old. So in today's video we're going to solve the initial value problem. X dy dx is equal to radical x squared minus 4 and x is greater than or equal to 2 and y of 2 equals to 0. Before we get started, please like and subscribe to the channel and share my video. Now let's get into it. First we're going to cross and multiply. We're going to get x dy is equal to radical x squared minus 4 dx. So now I divide x on both sides. So we get dy is equal to radical x squared minus 4 over x dx. So now I take integration on both sides. So we have integral of dy, we just name it y of x. This is equal to, we have integral of radical x squared minus 4 over x dx. So in order to find the integral of that, we use trigonometric substitution. So make x equal to 2 secant theta. So now dx d theta is equal to 2. We know the derivative of secant theta is secant theta tan theta. Tan theta. So now dx is equal to 2 secant theta tan theta d theta. So now let me erase this, and this. So now we have integral of radical. We know that 2 secant theta squared is 4 secant squared theta. We have minus 4 over x, which is 2 secant theta. And we have dx, which is times dx, which is 2 secant theta tan theta d theta. So now let me erase this, and this. So now we can cross out this 2 secant theta and this 2 secant theta. So you have integral. We can factor out the 4. And we have integral radical, we can factor out the 4. And we have secant squared theta minus 1, which is tan squared theta. And it's closed. And we have tan theta d theta. So now let me erase this, and this. So now same as integral. We know that radical 4 is same as 2. We have times, we know radical tan squared theta is tan theta, and tan theta times tan theta is tan squared theta, and then d theta. So now let me erase this, and this. So now I can take out the 2. You have integral of, we know that tan squared theta is the same as secant squared theta minus 1, and this goes d theta. So now same as 2 times, we know that the integral of secant squared theta d theta is tan theta. And then we have minus, no, integral 1 d theta is theta, and it's close to plus c. So now same as 2 times. In order to find tan theta, I had to make a right triangle. So now let me erase this, and this. So now make a right triangle there. So this is theta. And we know that secant theta is x over 2. And we know that secant is hypotenuse over adjacent. So you have x 2. And we know that tan theta is opposite over adjacent. And in order to find the opposite, we would use Pythagorean theorem. So you have 2 squared, which is 4, plus b squared is equal to x squared. So now we know that b is equal to radical x squared minus 4. So this will be radical x squared minus 4. So now we're going to say this 2 times, that tan theta will be radical x squared minus 4 over 2. And the minus, we know theta will be secant inverse x over 2. Parentheses closed plus c. So now let me erase this, this, this. So now we know that y of x will be equal to 2 times radical x squared minus 4 over 2 minus secant inverse x over 2, parentheses closed plus c. So now we know that y is a function of x, so we can plug in x equals to 2. And we know that y of 2 is equal to 0. So you have 0 is equal to 2 times, you have radical of, we know that 2 squared is 4, and 4 minus 4 is 0 over 2, and then minus secant inverse. We have 2 over 2, which is 1, parentheses closed plus c. So now we know that 0 is equal to 2 times, we know that radical 0 is 0, and 0 over 2 is 0. The minus, we know that secant inverse 1 is 0, parentheses closed plus c. So now we know that 0 is equal to 2 times 0 minus 0, which is 0, and 2 times 0 is 0. I know that 0 plus c is c. So now let me erase this, and this. So now that means that y of x is equal to 2 times radical x squared minus 4 over 2 minus secant inverse x over 2, parentheses closed. Now let's find the answer. Thank you guys for watching my video today.